Have you ever had your water tested before?
No, I haven't.
Oh, it's very interesting. It allows you to see what's in your water. The first test that we're going to do for you today is called the hardness test. So I've got a hardness tube here, and what we're going to do, we're going to fill this up with tap water to the 1 GPG mark. Now that stands for grain per gallon. Okay, we're going to fill it up with your tap water. I'm going to rinse it out a couple times. Just make sure nothing's in there from the last home that I was in. All right, and I'm going to be pretty accurate there. Does that look pretty good?
Yes, it does.
Okay. Now, we're going to add some chemicals. The first chemical that we're going to add is Agent 5. Now, what this is a hardness buffer. It's going to shock, or it's going to neutralize the impurities that are in the water. So we'll go 1, 2, 3, 4, 5. Shake that up. Now, the next chemical that we're going to add is Agent 6. Agent 6 is a dye. It's going to dye the water, or it's an indicator. It's going to indicate whether you have any hardness or not. So, if we drop this in there and it turns red, that means that you do have some hardness. If it were to turn blue, it means you have soft or you have treated water. So, we'll go 1, 2, 3, 4, 5. Shake it up, turns red. So, what that means is you do have some hardness. Now, the last chemical we're going to add is Agent 7. Okay? This is a chemical softener. This is going to tell us how hard the water is. Each drop of this represents 1 grain of hardness. Now, the goal is to turn the water from a red to a blue color. However many drops it takes to turn it blue, that's how hard your water is. So, we'll go 1, 2, 3, 4, 5, 6, 7, 8. So we're at 8 drops. So 8 drops means 8 grains of hardness. So based off of what the U.S. Department of the Interior says, if we look at their measurements, at 8 drops, that means that you have hard water. Okay? Now, hard water is hard on everything that it runs through. Okay? The Water Quality Association says hard water ruins plumbing at an estimated $6.7 billion per year. Okay? Hard water is going to clog and corrode your plumbing, choke your water pressure, block drains, okay? The average home contains thousands of dollars in plumbing, drains, fixtures, and appliances being deteriorated by the hard water. It destroys your faucets, your dishwashers, your shower heads, your water heaters, your washing machines, coffee makers, humidifier, and you, okay? It destroys everything that it runs through, okay? Now, I brought along a little portable unit here. In this unit is carbon and resin, and what it does is it kind of acts like a magnet does to metal, and it pulls the impurities that are in the water out of the water. So when I turn this on, you'll see when I add the filtered water in, do you see how the water stays blue? That's because we removed the impurities, okay? Now, when I add a little raw tap water back in, do you see how it turns it back to red? I'm sorry?
Yes.
Okay. Yeah, that's because the impurities have been added back in. Now, the next test that I'm going to do for you today is called the precipitation test, okay? That means to separate or to settle, okay? Allows the impurities to fall to the bottom. It's the only scary test I do. Lets you see what's in your water. So what we're going to do, we hooked back up our portable filter here. Again, in it is carbon and resin. It's just pulling those impurities that are in the water. It's pulling them out of the water. And we're going to fill one of these vials up right here, one of these test tubes up with the filtered water. We'll rinse it out. Again, just to make sure there's nothing in there from the last home. Okay? Then we've got an identical vial right here. We're going to fill this one up with tap water. Okay? So we'll fill that one up, rinse it out, and then we'll fill it back up. Okay? And now we're going to add some more chemicals. The first chemical that we're going to add is Precip A. Now this is potassium hydroxide. Okay, what this is going to do is it's going to bond, it's going to glue, it's going to clump the impurities that are in the water together. So we'll go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Next chemical that we're going to add is Precip B. This is hydroxyquinoline sulfate. What this is going to do is dye the water and help drag the impurities down to the bottom. So we'll go 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5. Okay? Now when I agitate these, you might notice a little bit of a difference. Can you see a little bit of the difference over here?
Yeah.
Here's your filter water, it's clear. Over here, it's just a little bit cloudy. That's the sediment, that's the hardness, that's the rock and debris. As we let it set, you'll start to notice a bigger and bigger difference, okay? Now, this is the hydrologic cycle, okay? This is 5th grade science, you probably already know this. Water rains down, runs off into our rivers, lakes, and streams. The H2O molecules, they evaporate back up into the air, and then it rains back down. You knew that, right?
Right.
Okay. The key thing about water, though, water is a universal solvent. So what that means is everything that it touches, it takes a little bit of it with it. It's the way that God designed the earth to clean, right? That's how our dead leaves, our trees, our manure, that's how everything breaks down over time. Would you agree with that?
I would.
Okay. Now, would you also agree this is probably what the world used to look like before the Industrial Revolution?
A few years ago, yes.
Yeah, a few years ago. What was there to pollute our water back then?
Not much.
Dinosaur poop.
Dinosaur. Okay.
Yeah. Not a whole lot going on but the poop. Okay. Would you agree this is kind of what the world looks like today?
Oh, yeah.
Okay. Look at all the new things we have to pollute our water. Plastic, construction debris, pesticides, insecticides. Farming, ranching, agriculture, you get lead, mercury, oil, gas byproducts, sewage, stormwater, drain runoff, pharmaceuticals. Now, we had 100 million people in the U.S. in the 1920s. We had 200 million people in the 70s. We had 300 million people in 2006. Now, more people means more of all these pollutants to the earth. Would you agree?
Yes.
Okay. Now, does water come in contact with all these?
All of it.
Yeah. So doesn't that mean we're having to see more and more of it back in our water sources?
Oh, yeah.
Now, here's the question. If something this size can slip through the city water treatment process, what do you think the chances are any of these chemicals that I just brought up are slipping through?
Very high.
Okay. Now, do you know what the city does to prepare your water?
No.
Okay. One of the things that they do is they put chlorine in the water. Have you ever seen one of these?
I've seen it in school, but no.
Okay, it's a boil tester, right? You can check your chlorine, you can check your pH levels, and what we're going to do is we're going to check your chlorine levels right now, okay? So we're going to fill up the yellow side for chlorine. All right, then we're going to add a chemical. Now this is called OTO, okay? Orthotolidine. It's a chlorine indicator, it's a chlorine detectant. You go buy one of these, a little bottle of this, comes with it with the yellow cap. It's how you indicate your chlorine levels. So we're going to go 1, 2, 3, 4, 5. Okay, now I'm going to agitate this just a little bit. And if we take a look, it's going to show us your chlorine levels. You can clearly see that we have chlorine in the water, right?
Very clear.
All right. And if you color code this up right here, wouldn't you agree we're coming right at about that ideal level?
Yes, we are.
So you have ideal chlorine levels, right? So there's good news and there's bad news, right?
Right.
It's safe to go swimming in your bathtub, right?
Yeah.
It's the ideal levels for a swimming pool. Okay? Now, our aim is to improve your water, okay? Hey Quality Water does not endorse water pollution articles. We simply want to improve on nature's impurities, okay? This is what the city does to treat our water. The first thing that they do is they pull in the water, okay? It goes through a treatment process where it's hit with lime, okay? The lime, it's a chalky rock. It's there to bond, glue, clump the impurities that have been pulled in from the river, a lot like our Agent A is attempting to do right there. Then it gets hit with alum. Alum's real name is aluminum sulfate, okay? That's there to soften up the water, okay? Then it gets hit with chlorine. The chlorine, again, it's there to kill the bacteria, okay? Then it goes through coagulation, flocculation, and sedimentation. Now, that's a separating and settling process where all the stuff that the lime bonded or glued together, you can see it's kind of settling away from the water.
Yeah.
And the last stage is sand and gravel filtration, okay, which is big rocks, smaller sand, smaller sand, and smaller sand. It's usually about 6 stages. And again, that's separating even more stuff away from the water. Then the last thing it's hit with at the very end again is chlorine, okay? They use chlorine down here to kill with. Then they use that same killer down here to protect the water as it travels through the pipes to our homes. Okay, now let's say I invited you over to my house for a barbecue, right? You pull up to my house and you see me with this big 55-gallon drum, okay? And you see me dump a bunch of different size rock and sand and gravel into this 55-gallon drum. Then I take a couple bottles of Clorox, dump it in there, okay? Then I start taking pictures of the Missouri River, Okay, pitchers of that water, dumping it into this 55-gallon drum. I fill it all the way up to the top. I put a lid on top of it. I shake it up real good, and I pour you a glass of water. Are you going to drink it?
No.
But isn't that kind of what you're doing right now?
I guess so.
Yeah. Okay, let's say you win a trip to New York, right? Win a trip to New York. Now, if you go to New York, you got to go through Central Park, right? It's just a tourist site you got to see. So you're walking through Central Park. You look over to the left and you see a park bench. Now, on the park bench is a big sign. It says free homemade sandwiches. And there's this delicious looking platter of these homemade sandwiches. Now, no one's around, but they're free and they're for you if you want one. Are you going to walk over and eat one of these sandwiches?
No.
Why not?
Well, I don't know who did it.
You don't know who made it? You don't know what's in it? You don't know how long it's been? You don't know anything about it. You wouldn't dare put it into your body, right?
No way.
But isn't that kind of what you're doing right now?
I guess so.
What if it said free homemade government-made sandwiches? Then you'd eat them, right? Okay. Now, the next test, I need some help. So I'm going to have you come on up to the sink, okay? All right? And I'm going to have you stand right over there. All right? Now, what we're going to do, we're going to take one of these glasses, fill it up with tap water. We're going to take the other glass. We're going to fill it up with tap water, okay? Now, what I want you to do, I want you to take a small drink of that. Just kind of swish it around in your mouth, just like mouthwash. Really swish it around. When you think your mouth is nice and cleaned out, I want you to go ahead and spit it back into the sink. Okay? Take a little bit bigger drink. Do the same thing. Take a little bit bigger drink. Do the exact same thing. Swish it around your mouth. I want you to really swish it around. But this time, don't spit back into the sink. Just keep swishing it around. Okay? You remember how Dory kept swimming? You keep swishing. Okay? All right. Now, what I want you to do, over the sink here, I want you to spit back into that glass. Okay? Perfect. Thank you, sir. And you can go ahead and have a seat. Okay? So we've got your spit water right here. Okay? And we're going to equal up our tap water so it's about the same levels. Okay? And what we're going to do, we're going to take that OTO. Okay, now that's that chlorine indicator again. We're going to go 1, 2, 3, 4, 5. And then in our tap water, we're going to go 1, 2, 3, 4, and 5. Okay? Now, when I swirl these around, you might notice a difference in the two. Okay? Here's our tap water. It's starting to turn yellow. Okay? Yeah. Which means it's indicating chlorine. Over here, there's no sign of yellow. What happened to the chlorine?
I guess I drank it.
Well, you absorbed it, right?
Okay.
In a matter of 5 to 10 seconds, not only the chlorine, but maybe any other chemicals that could have been in that water could now have been absorbed into your body. 3 ways chlorine can affect you. You can absorb it, you can inhale it, and you can drink it, ingest it, okay? Hidden dangers of your morning shower. Chlorine is a gas used in all municipal water supplies to disinfect the water. Okay? Tests have shown that you absorb more chlorine in a 10-minute shower than by drinking 8 glasses of the same water. What happens is a warm shower opens up your pores, causing your skin to act like a sponge. As a result, you not only inhale the vapors, you also absorb them as well. Okay? Now, how important is it for your family to have bottled quality water? Okay? Doctors recommend 7 to 10 glasses a day. Okay? Water is the single best catalyst for weight loss. Okay? Your skin and hair depend on water. Okay, clean water is the fastest way to a healthy body. What good is proper nutrition, exercise, and healthy living without clean water, you think?
Not very good.
Not very good, okay? Up to 65% of the human body is made up of water. Okay, lungs are 85% water, kidneys are 83% water, brain 83% water, blood's 94% water, okay? Heart is 75% water, muscles 75% water, okay? Now, if the city came by today to run a separate water line down your street and they promised you good Hague Water Max water and they said, hey, your water bill's not going to change, you would do it, wouldn't you?
Yeah.
Okay.
Yeah.
Now, our company's policy is to not come out and knock the city. We're not out here to say the city's doing a bad job. Okay, the city's doing an amazing job. Okay, the problem is 98% of the water that's pushed through a water treatment plant every day is going to go to commercial and industrial use. Okay? Now, that water doesn't need to be good. It just needs to be treated. Now, about 2% of what the city cleans is for residential or for human use. Now, I think we agree that water should be good, right?
It should be great.
But to give us a better quality of water, would it cost more money?
I would think so.
Yeah, and who do you think would have to pay that additional cost?
Well, the consumer.
The taxpayers.
Mm-hmm.
We would, right?
Right.
Okay. The city doesn't do more for us because it's just not cost efficient. It just doesn't make sense.
Mm-hmm.
So more and more people, what they're starting to do now is pick up where the city leaves off. Okay, that's where we come into play, mechanically treating the water. What a lot of people are treating our industry like is just like home security systems. Okay, you've heard of ADT, right? The home security systems. Okay, mid to late 70s, inner city population started to rise, violence started to rise. Okay, so people started to get these home security systems to protect their families from intruders. Well, instead of getting a home security system, why didn't we just put a cop on every block in the U.S.? Think about that. One cop, one block throughout the entire U.S. Now, would crime go down?
Probably.
Most likely,
Most
right?
likely.
So why not do it?
Cost.
Couldn't afford it, right?
Mm-hmm.
Just not cost efficient.
Mm-hmm.
So what people do? They picked up where the city left off, right? With the home security systems. Well, just like people want to protect their family from intruders, more and more people are seeing the need to protect their family when it comes to their water issues. Okay? Now, for my next test, I need to borrow a towel and a bowl. Can I borrow this towel right here? Okay, perfect. And I'm going to borrow a bowl. And what we're going to do you have a bowl down here somewhere maybe? All right, we're going to borrow this bowl right here. And we're going to soak this in the filtered water. So I'm going to hook back up that portable filter. And we're going to soak this towel in the filtered water, and then we're just going to set it aside.